Hey everyone, so here is day 2 of graphing polynomials, and today we're going to focus on something called multiplicity. It's not super hard, I think we're going to be okay with it. Alright, so this is a review from the quiz, so factor completely. So the first thing you want to do is count 6, how many there are 6, and I also noticed that there are 2 variables in here that makes a difference. When we have 6, it's either, oops, turn my pen on. It's either going to be a 3 and a 3 or a 3, 2, 1. Right? That's how I think about it, at least. So I know the first 3 are going to go together. Look at that. That's a difference of perfect squared, or that is a perfect squared trinomial. And then when I look at the second 3, notice I have the x minus y. Well, right here, this is going to be a 3, 2, 1. I divide by -5 as a GCF. Uh-oh, I messed this problem up. And you get x plus y. Okay. Clearly, I need to edit this problem on the lesson. Make that a plus. So it's x minus y squared minus 5 x minus y minus 84. So now this is a trinomial. A squared minus 5a minus 84. So we're multiplying to negative 84 and combining to negative 5. That's 7 and 12. So x minus y is my a. X minus y. We are subtracting 12 and adding 7. Done. Okay, so based on what we learned the other day, I want you to sketch this. So we always start with our roots. My roots are 0, -2, and +5. Now this is a nice smooth curve. So now what I'm going to do is I'm going to think about the end behavior. As x goes to infinity, what's happening to my y? If I plug in a really big positive number, I get a negative times a positive times a positive. So it's going to be negative infinity. That means this is going down. If I plug in a really big, a negative number, right? If I plug in a negative, I get a negative times a negative is a positive. A negative plus 2 is still going to be negative. A negative minus 5 is still going to be negative. So I've got 2 negatives, so that's positive. So positive infinity. So that means my arrow is going up. And then I'm just going to connect and make a nice smooth curve. Okay, so now what if I had x cubed minus 4? That's not factored. We could try to factor it, but it's not very nice. So now take a get. Just kind of like mess around with it, see if you can figure it out. So think about what x squared minus 4 is. That's just a parabola shifted down 4. So x cubed minus 4 is a regular x cubed function minus 4. So try plugging numbers in. So we're at -4, right? And then let's say I plug in 1. What do I get if I plug in 1? -3. If I plug in 2, I get 8 minus 4, right? And then same thing kind of here, because it is, so this thing actually looks like this. And that's an x cubed problem, looks like that. It's always increasing, but it's got this weird, like, it's called an inflection point right there. Okay, so same idea. We're using the fact that the inflection point, or the x cubed, looks like that, right? So based on that, what would these look like? So we're shifting left 4, up 1, right? And then we're just gonna kind of, the 2 just expands it. So it's just like that. And then 5, -7. Right, so 5, -7. And it's negative in front, so it's gonna go upside down. So it's gonna be like that. Ugh. I'm so bad at drawing these. So it has the same shifting rule as a parabola, but instead of using, the U-shaped curve, we're using the parent function, which looks like that. Okay, so sketch the following parent functions. So pause the video and do these. So y equals x is a line, x squared is a parabola, x cubed we just talked about, it looks like this. What's x to the fourth? X to the fourth is just a skinny parabola, right? Because like 2 to the fourth is 16 instead of 2 squared is 4. So x to the fifth looks like x cubed but skinnier. And then x to the sixth is even skinnier than the x to the fourth. That's it. So notice odd functions, arrows are going in opposite directions. Even functions, they're going in the same direction. All right, so let's take a look at this one and see what happens. Let's start with our roots. All right, our roots are 5, 0, and negative 2, 0. So I'll make that my 5, and this my negative 2. So I only have 2. Notice I only have 2 roots. Now let's think about our end behavior. As x goes to infinity, as I plug in a really big positive number, 1,000,000, I get a plus and a plus. So my y is going to infinity. So this arrow is going up, right? And then as x goes to negative infinity, what's happening? So I plug in a negative minus 5 is still negative, and then I have a square, so that's positive. So we get negative infinity. So this one's going down. But now here's the question. How do we connect these? Is it going to come down? Is it going to go up? What's happening between these two numbers? So one way to check is to just kind of pick a number between them, right? Pick any number between 5 and negative 2. How about 0? If I plug in 0, right, think about that's just the y-intercept. 0 minus 5, 0 plus 2 squared. What do we get? We get negative 5 times 4, negative 20. So negative 20. So that means this has to come down, and somewhere around there's a we don't know where the midpoint, oh my goodness, my brain is not working. We're not really sure where that minimum point is. It's somewhere between negative 2 and 5. The symmetry doesn't work the same with polynomials. Wow, Monday morning. All right, so now what do we notice about this? What's happening at the root negative 2? At negative 2, this has what's called a multiplicity. If you kind of zoom in, that looks like a parabola to me, right? Around negative 2, there's a parabola. So because of that exponent of 2, around that point, we're going to have something that looks like a parabola. It hits the x-axis and comes back. So that's something you want to keep in mind. All right, so now let's look at what's going to happen with this one. So start by finding your zeros again. So I've got my roots. I've got negative 8, positive 12, and positive 4. Negative 8, 12, and 4. All right, as x is going to a positive, I don't have any negatives, right? So plus, 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 so we're going up. Negative, as we're going to negative infinity, we get a negative, a negative, a negative, so it's down. Right. So we want to just have the graph look like this. That's not actually what happens. This 3 causes something to happen. Remember, what does an x cubed look like? It looks like that. It's got that little, I like to call it a spaz out point, kind of. So what's happening is that, kind of like with the last one where it had the little parabola there, at 4, it actually has a little curve to it. It's kind of like that, where it's got this inflection, an x cubed kind of going through the 4. I did not do a great job, but at 4, you need to draw in something that looks like an x cubed. Let's see. That's a little better. All right, so that's my graph. Right. It can't just go smoothly through. It has that little inflection point, spaz out point, as I like to call it. Okay, so multiplicity is the number of times a particular number is a root or zero of a polynomial. The sum of the multiplicities equal the degree. So the degree is your highest power. If I were to multiply this whole thing out, my degree, I can spell. Wow, I'm really struggling this morning, guys. My degree would be 2 plus 4 plus 1 plus 5. So that's 6, 7, 8, 9, 10. So my degree is 10. So my x equals 0 has a multiplicity of 2 because it's an x squared. My negative 6 has a multiplicity of 4. 2 has a multiplicity of 1. And 9 has a multiplicity of 5. Right? So at each of those points, at 0, it's going to have something that looks like a parabola. At negative 6, an x to the 4th. At 2, it's just going to go smoothly through. And at 9, it would have a 5. Okay, so why don't you pause and try this one on your own. Okay, so our zeros are 0, negative 8, and negative 1. 0 has a multiplicity of 2. Negative 8 has a multiplicity of 1. And negative 1 has a multiplicity of 3. What is the y-intercept? If I plug in 0, what do I get? Well, that's a nice easy one. I get 0, 0. End behavior. As x goes to infinity and as x goes to negative infinity, what is happening to this graph? Let's see, infinity. I get a negative, times a positive, times a positive. So negative infinity, because of that negative in front. X goes to negative infinity, we get still that negative in front of the x squared, and then another negative, and then another negative, so negative infinity. Negative 8, 0, negative 1, Alright, let's make these blue so it's a little nicer looking. Alright, so negative 1 is on the end, so we're going down here, and then we're also going down over here. Alright, so remember what's happening at negative 1. It's got a multiplicity of 3, so we're going to have an x cubed looking thing going through it. So that's why, even though I draw it down, I'm gonna fix that. So it's going to look something like that. And then what's happening at 0? 0 has a multiplicity of 2, so it's going to have a weird looking parabola thing. There's my little parabola, and then it goes up and goes through negative 8. So pretty ugly, but I mean, it's basically, yeah, that's what the thing looks like. They're tough to draw. Yours might be better than mine. I'm better on a whiteboard. All right, pause and try it on your own. So we've got 0, 0, 0, 0, negative 8, 0, 5, 0, and 4, 0. The y-intercept is 0, 0. As x goes to infinity, it goes to negative infinity. Let's see. So we've got a negative infinity, so a negative times a positive times a positive times a positive, so negative infinity. And then negative, we've got a negative times a negative times a negative times a positive because it's squared, so that's negative infinity. So negative 8, 0, 4, and nope, it's too far away. 4 and 5. No zeros. All right, so x goes to infinity, we're going down. And 5 does not have a multiplicity. This one's 8 is also going down. That one does have a multiplicity, though. It has a multiplicity of 5, so it's going to look like an x cubed. So something like that. And then, let's see what's happening at 4. We have a parabola, so it's going to go up and back. And then 0, it's just going to go through 0. What happened? I did something wrong. What did I do wrong? Did I forget one? No. You know what? I messed up the negative 8. So it's negative, so that's the negative x, and then negative x to the 5th, and then a negative, and then negative squared. So it's actually positive because there's 1, 2, 3, 4, positive infinity. So I messed that up. It happens. All right, so this is gonna go like that. Ugh, why am I so bad at doing this on my iPad? I'm so much person. All right, let's try that again. Come down like that. All right. So make sure it goes, and like I've had students just like write me a note, especially on a quiz, like, oh, I swear that's an inflection point. I swear it's got the little spaz out point. All right, now you need to factor. So we're gonna factor and then graph it. So pause the video and try this one. All right, so I'm gonna factor out negative x squared first. So we got x squared minus 10x plus 25. So that is just x minus 5 squared. I like this problem, I'm not gonna lie. All right, so my roots are 0, 0, and 5, 0. And both of them have a multiplicity of 2. My y-intercept is 0, 0. As x goes to infinity, y goes to positive infinity. I'm lying. Yep, negative infinity. And as x goes to negative infinity, we go to negative infinity. And all because of that negative that's in front, right? So the positive big numbers are getting squared, but there's still that negative out front. All right, so all I need to put on here is 5. I'm going to do green. So I got my zeros. So there's going to be a parabola-looking guy at x squared and at 5. So I'm going to come down. They're both going down. So I'm coming down and then back up and then down. So it just looks like an M. This one's pretty easy. Okay, extrema, the turning points of the graph. So extrema is just a phrase that we use like to represent both the max and mins. So we've got that point, this point, this point. It's just a general term. We don't really have a way to find the x values of the extrema. We know if they're close to the midpoints, like it is in the parabola, but the symmetry is not as nice because of when things are shifted up and down. It kind of messes with where the points of extrema are. So in Algebra 2, we don't have a good way to do it, so the only exact way to do it is using a calculator. When you get to calculus, we do have an exact way to do it, but in Algebra 2, we don't. But we can estimate them by using the midpoints. All right, homework, practice. Have a great day.